Okay, for topic two, we're going to talk about the fundamental counting principle. Okay, and the fundamental counting principle is going to make what we did in the previous video with counting and tree diagrams, it's going to make it a bit easier. Okay, so the fundamental counting principle says the following. It says if you have a sequence of events where the first event can occur in m ways and each subsequent event can occur in n ways, then the total number of ways the entire sequence of events can occur is m times n ways. What in the world are they talking about? Well, let's go and investigate. Let's figure out what this definition is saying to us. So, in the previous example, we talked about counting, which refers to the technique used to determine the number of possible outcomes or arrangements of different situations, and we used tree diagrams, which is just like it's like a graphical, like visual representation of this. Okay? So we built these tree diagrams. And in the first example, we were talking about, okay, how many different outfits could we create if we had 4 shirts and 3 pairs of pants? Well, we found that we could create basically 12 different outfits. Well, there were two components, two things that we were looking at when we were creating these outfits. We were looking at shirts and we were looking at pants or shorts, let's say pants. Okay. So here's what this fundamental counting principle definition was saying. It was saying, hey, you have these two things, they can occur in different ways. So, this first thing, the number of shirts could occur in 4 different ways, the pants could occur in 3 different ways. If we just multiply the ways each of these things could occur, we can get the total combinations between the two. Okay. So if we take 4 shirts, multiply it by the 3 pairs of pants, we get 12 outfits, which is exactly what our tree diagram showed us. So let's go back up here or down here and read this definition again, but we're going to talk specifically shirts and shorts, okay? So the fundamental counting principle states that if you have a sequence of events where the first event, shirts, can occur in m 4 ways, and each subsequent event, pants, can occur in n ways, 3 ways, then the total number of ways the entire sequence of events, outfits, can occur is m times n, or 4 times 3, which equals 12 ways. So again, each event occurs in a certain number of ways. So the shirts have a certain number of possibilities, the pants have a certain number of possibilities. If we multiply the possibilities for each, we get all the different sequences that we could create out of those two events. Okay, with the Happy Meals, we had 3 different ways that we could I'm going to write it here. So we had the main course, and then we had the side item initially. So we had 3 main courses. You could have gotten chicken nuggets, a hamburger, or a cheeseburger, and then we had 2 sides. So that gave us the 6 meals that we could create initially. But then I was like, hey, let's go ahead and throw in drinks. Let's say that we could have drinks, and I think for the kids' meal, it's generally milk and soda. So times a drink. Well, there were 2 drink options. So that gave us 3 times 2, which was 6 initially. But then each of those 6 meals has 2 options for a drink. So that is 12 different Happy Meals. Okay, so you take each component of the sequence or the combos that you're looking at. You take each component, figure out how many ways that component could happen, multiply those for each component in the list, and then you get however many combinations or how many different sequences could be created. Okay, so let's look at an example. So use the FCP, that's the fundamental counting principle, to determine the number of different outcomes for each event. Okay, so a restaurant offers 5 types of appetizers, 6 types of main courses, and 4 types of desserts. How many different 3-course meals could you order? I'm sitting here envisioning the Applebee's commercial for like the 3 for me or something. It's like 10.99 and you get an appetizer, a main course, and a drink or something similar to this right here. So how many different ways could you order a meal here? Okay. So how many different outcomes for meals could be created with appetizers, main courses, and then dessert? Okay. Well, we had 5 appetizers. We had 6 main courses and we had 4 desserts. So, how many different meals could we potentially order? So, we could order 5 times 6 times 4. What's that? 120. So, there are 120 different meals that could be ordered. So you're basically matching each of the 5 appetizers with each of the 6 main dishes, and then each of those combinations gets matched with the 4 different desserts. So there's 120 different ways you could order a 3-course meal at this particular restaurant. Okay. And do you see why this would maybe not be the most fun to do a tree diagram? We could. It would take forever and it would be enormous. It would be like huge, but we could do a tree diagram. It wouldn't be fun. It'd be super tedious. Okay. But this is why we have the fundamental counting principle, because the tree diagram can get huge and out of control real fast. Okay. Now for part B, it says imagine a password is composed of 5 digits from 0 to 9, where the first and last digit of the password cannot be 0. So you're looking for some kind of a passcode, like a passcode to a gate or a door or something. Okay. And we know it is composed of 5 digits. So we have 5 different slots for numbers. Okay, we know the digits possible are from 0 to 9. So let's actually talk about 0 to 9 because you'd be amazed how many students get this wrong. The digits from 0 to 9 are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. How many different digits are there? Well, there's actually 10. So there are 10 possibilities. Possibilities. Okay, people forget that 0 is its own little critter, so there's 10 possible single digit numbers out there. Okay, now we're told that the first and last digits can't be 0. So that means this one can't be 0, and this one can't be 0. Okay, but the other digits in between, the other 3 in the middle, there's no condition. There's no like issue with those 3 in the middle. So let's create the passwords. Well, for the first digit, it can be anything but 0. So that gives me 9 possibilities. So it could be the digits 1 through 9. Okay, the middle 3 digits in our passcode, there's no limitation. So there's 10 possibilities for these. And then my last digit in the passcode, again, can't be 0. So that leaves me only 9 possibilities instead of 10. So we can multiply this out and we get 9 times 10 times 10 times 10 times 9. So we get 81,000 possible passcodes. So again, would you want to do the fundamental counting principle or would you want to do a tree diagram? I cannot fathom a tree diagram with 81,000 branches on it. Okay, so this is why we have the fundamental counting principle. This would be, I'm not going to say impossible, but this would be nearly impossible to do by hand. Okay, and it would take 67 eternities to do it. Okay, so this is the fundamental counting principle. It's nice, it's slick. It makes finding the number of different ways something can happen very easy to figure out. Okay. So that, I think, yeah, that's it. So we've got counting and tree diagrams, and then we've got the much more efficient fundamental counting principle. In the next video, we will talk about probability.